Good day, guys. Today I'm going to continue our discussion of continuity of a function. But this time I'll be talking about more on types of discontinuity. Let us have the following exercises. Identify the value of x at which f is discontinuous. Tell if it is a removable, a jump, or an infinite discontinuity. Let us have our first example. F of x is equal to x squared minus 1 all over x minus 1. First, let us determine the domain of this function. The domain of this function is given by set of all x such that x is not equal to 1. So meaning from negative infinity to less than 1, union with 1 to greater than 1 to positive infinity. Okay, so meaning 1 is not included in the domain. So possible discontinuity at x equals 1. Let's test the three conditions for continuity at 1. So first condition, we have the value of the function when x is 1. So that is 1 squared minus 1 over 1 minus 1, right? So, and that gives us 0 over 0. And this is not a real number. So it is undefined. So guarantee that this function f is not continuous at 1. But let's see the limit in order for us to determine what type of discontinuity is involved. So for the second condition, we have to get the limit of f of x. So that is x squared minus 1 all over x minus 1 as x approaches 1. Okay? So the numerator approaches 0. The denominator approaches 0. Hence, this is indeterminate. So we can apply, in order to get the limit of this, we can apply factorization method. Let's factor the numerator. That is x plus 1, x minus 1. The denominator is still x minus 1. Hence, x minus 1 is cancelled. So getting x plus 1. Since x plus 1 is a polynomial, we can apply direct substitution here. So the limit, therefore, is equal to 1 plus 1, and that is equal to 2. Okay? Since the limit at x equals 1 exists, but not equal to f of 1, so it means that this is what? A jump, a removable discontinuity. Okay? So again, so here, f of 1 is not equal to the limit of f of x, but the limit of f of x is equal to what? Is equal to 2. It exists. This limit exists. Hence, this is of type removable discontinuity. So again, we can conclude that f is discontinuous at x equals 1. What type of discontinuity, guys? So f has what? F has a removable discontinuity at 1. Okay? So let's have number 2. So let's say our f of x is given by this piecewise function. It is square root of 2 minus x if x is less than 2. And it is 2x minus 1 if x is greater than or equal to 2. So again, we first determine its domain. The domain of f is the set of all real numbers. So that is negative infinity to positive infinity. The possible discontinuity is at x equals 2. So let's see if the graph of f of x equals square root of 2 minus x if x is less than 2 is connected to the graph of f of x, which is equal to 2x minus 1 if x is greater than or equal to 2. So let's check the function value. Although we know that it is defined, but the value is f of 2, and that is equal to, the value is 2 times 2 minus 1, and this is equal to 3. What about the limit? From the left of 2, so we have limit of square root of 2 minus x as x approaches 2 from the left. Since the limit of 2 minus x as x approaches 2 from the left approaches 0 through positive values, we can apply direct substitution rule. So we have 2 minus 2, and that is equal to 0. What about limit as x approaches 2 from the right? We're going to use 2x minus 1. And this is actually equal to the function value. That is 2 times 2 minus 1, which is equal to 3. Both limit from the left and limit from the right exist, but not equal. So these two are not equal. Therefore, limit of f of x as x approaches 2 does not exist. For what reason? Limit from the left and limit from the right, although they both exist, but they are not equal. Okay? Since the function value, which at 2, which is equal to 3, is not equal to the limit of f of x as x approaches 2, but the function value exists, but although not equal here, so we say that f is what? Is discontinuous at x equals 2. Okay? But what type of discontinuity is involved at x equals 2? Since f has a jump discontinuity, at x equals 2. Am I right, guys? Okay. So again, what's the reason why it has a jump discontinuity at x equals 2. The limit at x equals 2 from the left, it exists. The limit at x equals 2 from the right, it also exists, but they are not equal. Hence, f is discontinuous and has a jump discontinuity there at x equals 2. Okay? Let's now proceed to number 3. So for number 3, we have, let's say, f of x is equal to 3x over x minus 1. Okay? So let's see. The possible point of discontinuity here. For the domain of this function, the domain is, again, from negative infinity to less than 1, union with greater than 1 to positive infinity. So meaning all real numbers are accepted except when x is 1. So obviously, it is not discontinuous. It is discontinuous at x equals 1. So again, discontinuous at x equals 1. So that is the possible discontinuity, point of discontinuity. So to verify that it is really a discontinuous at x equals 1, the function value at 1 is what? 3 times 1 over 1 minus 1, and this is equal to 3 over 0, and this is undefined, meaning it's not a real number. What about the limit? The limit as x approaches 1, let's see coming from the left first. 3x over x minus 1. So what's the limit? The numerator, the limit is going to be 3. This approaches 0 through negative values because from the left of 1, so meaning x is less than 1. Less than 1 minus 1, expected difference is negative. So this is approaching 0 through negative values. So hence, the numerator going to be positive 3, the denominator going to be 0 through negative values, therefore it is negative infinity. Okay? What about limit from the right of 1? So as x approaches 1 from the right, so 3x over x minus 1, the numerator again approaches 3, that is positive 3, the denominator, since this time x is greater than 1, the difference, greater than 1 minus 1, so that is positive. So going to be 0 through positive values. So hence, the limit of this quotient is positive infinity this time. So we say that the limit of this f does not exist because from the left going to be infinite, from the right going to be negative infinite from the left, going to be positive infinity from the right. Okay, negative infinity from the left, positive infinity from the right. So we therefore conclude that f of x limit at x equals 1 does not exist. Therefore, we say that f of 1 is not equal to the limit of f of x at 1. No? So we conclude, of course, f is discontinuous at x equals 1. What type of discontinuity is involved at x equals 1? Since the limit from the left of 1, from the right of 1, both infinite, negative, and positive respectively, we say that f has an infinite discontinuity. An infinite discontinuity at that point where x equals 1. Okay? Is that clear, guys? What about number 4? So let's say we're given this function, piecewise function, that is x squared minus 4 all over x when x is not equal to 0. And it is equal to cosine x if x is equal to 0. Okay? Solution. Domain of this function, negative infinity to positive infinity. Okay? So, but there is a possible discontinuity at x equals 0. Possible, although the domain is a set of all real numbers, but there is a possible discontinuity at x equals 0. So let's see the behavior of the function at that point where x equals 0. The function value at 0 is given by cosine 0, and that is equal to 1. What about the limit? The limit, as x approaches 0, both from the left and from the right, so the function is x squared minus 4 all over x. Okay, so from the left, so let's see. If x approaches 0 from the left, the numerator is going to be negative. Limit of x squared minus 4 is going to be what? Negative. As x approaches 0. Minus 4. So again, approaches negative 4. So as x approaches 0. Okay? So that is positive infinity as x approaches 0 from the left. If x approaches 0 from the right, so we have negative 4 is still in the numerator, but in the denominator, it's going to be positive. Okay? So again, the denominator, if x is approaching through positive value, I mean through approaching 0, from positive, from the right, it is negative infinity. Why? Because the numerator is negative, the limit. The denominator approaches 0 through positive values. So negative over positive. So we have negative infinity. Okay? Since the limit is infinite, from the left positive infinity, from the right positive infinity, so we say that it is discontinuous, and the type of discontinuity at x equals 1, I mean at x equals 0, is infinite discontinuity. Okay? So although the limit, but through this case, the limit, we can say that the limit of x squared minus 4 all over x as x approaches 0 does not exist. But infinite from the left, infinite from the right. So therefore, we have all the different signs. So we have what? We have an infinite type of discontinuity. So let's finalize. F is discontinuous at x equals 0, and F has an infinite discontinuity at x equals 0. Another interpretation that we can get out of this at x equals 0 is that x equals 0 is a vertical asymptote of the function. Okay? What about number 5? Or no, number 5. So our function is given by this piecewise function. F of x is equal to, there are 3 expressions defining this function f. So we have the square root of 1 minus x if x is less than or equal to 0. It is the greatest integer of x if x is between 0 and 1, and then it is the absolute value of x if x is greater than 1. Okay? So let's determine first its domain so that we can easily identify points of discontinuity. The domain of this function, this piecewise function, is given by, it is defined at 0, no? But not defined at 1. Therefore, and it to the left of 0 included, to the right of 1 included, between 0 and 1. So hence, it is negative infinity to 0. 0 is included, so I will have up to 1, but less than 1 union with greater than 1 to positive infinity. There are 2 possible points of discontinuity. Obviously, discontinuous at 1. But let's see also if it is discontinuous really at 0 or not. So possible discontinuity at x equals 0 and at x equals 1. So first, let us have at x equals 0. The function value at 0 is square root of 1 minus 0, we use the radical, and that is equal to 1. What about the limit? So this is one-sided limit. Limit from the left of 0, we use square root of 1 minus x. So we can use substitution rule here because x is less than 1. So guaranteed, this is what? This is not going to be 0, no? So it is 1 minus 0. So it is equal to 1. Okay? What about limit from the right? As x approaches 0 from the right, we use greatest integer of x. If I'm choosing values to the right of 0, but less than 1, all values here between 0 and 1, this is what? Equal to 0, this greatest integer. So the limit of 0 is 0. So the limit of the greatest integer of x as x approaches 0 from the right is it is equal to 0. Okay? Since these two, although they both exist but not equal, so we say that f is discontinuous at what? At 1. No? Sorry, at 0. Okay? So again, since f of 0 is not equal to the limit of f of x, because the limit of f of x does not exist, although both the limit from the left and from the right both exist. So we say that f is what? Is discontinuous at 0, although the function is defined there at x equals 0. Okay? What about the type of discontinuity involved at x equals 0? So since both the limit, since both the limit of f of x as x approaches 0 from the left and from the right exist but not equal, so they both exist but not equal, so we say that what? F has a jump discontinuity at x equals 0. Again, if both the limit at x equals a from the left and limit of f of x at x equals, let's say, a from the right, they both exist but not equal. So we have a jump discontinuity. Okay? What about at x equals 1? So at x equals 1, we know that it is discontinuous there because it's not in the domain. But what type of discontinuity is involved? Okay? So we know that the function value is not defined, is undefined, or does not exist. Okay, guys? What about the limit there? So limit as x approaches 1 from the left, we are going to use the greatest integer. If you have value, let's say I have 1 and this is 0, I want values to the left of 1 but greater than 0. If you have values to the left of 1 greater than 0, so the greatest integer is 0. So this is what? 0 as x approaches 1 from the left. Okay, guys? So what's the limit therefore? 0. What about limit from the right of 1? From the right, we use absolute value of x. So, and the absolute value of x is, from the right, it is simply x. Because to the right of 1, this is guaranteed to always positive. So the limit is 1. So hence, limit of f of x does not exist. For what reason? As x approaches 1, because the limit from the left and limit from the right, although they both exist, but not equal. Okay? So these two are not equal. Not equal. So we say that f of what? F of 1 is not equal to limit of f of x as x approaches 1. So we say that f is what? F is discontinuous at x is equal to 0. Okay? But what type of this? Sorry, at x equals 1. We're now at x equals 1. Again, f is discontinuous at x equals 1. What type of discontinuity is involved? F is, or f has, a jump discontinuity at x equals 1. Okay, guys? Well, let's have number 6. So our function is given by f of x, and it is equal to absolute value of x over x if x is not equal to 0, and it is equal to 2 over x minus 1 if x is equal to 0. Okay? So let's see the domain, because the domain will help us determining the point of discontinuity. So take note that even the function is defined at a given value of x, it doesn't mean it is continuous there. Possible to be discontinuous. So the domain is the set of all real numbers. But there is a possible discontinuity at x equals 0. Okay? So first, let's check the function value at 0. So since it is in the domain, for sure it is what? Defined. And that is 2 over 0 minus 1. We use this second expression defining the function, getting negative 2. Okay? What about the limit? So the limit as x approaches 0. So from the left, we have absolute value of x over x. So we have limit. So from the left, the absolute value is negative x by definition. So over x. So as x approaches 0 from the left, this is equal to negative 1. Therefore, the limit is what? Of this constant, which is negative 1. So it's negative 1. Okay? What about limit from the right of 0? So we have absolute value of x over x, but this time, this absolute value is x. So over x, so as x approaches 0 from the right, so what's the limit? So this is limit of 1. As x approaches 0 from the right, so we have 1. Function value exists or is defined. Limit from the left and limit from the right exist. But this limit at x equals 0, since both from the left and from the right, although they exist, are not equal, we say that the limit of f of x as x approaches 0 does not exist. So we say that f is discontinuous at x equals what? 0. Because the function value is not equal to the limit. Okay? What type of discontinuity is involved? So f has a jump discontinuity at x equals 0. Okay, guys? Because, again, limit from the left, limit from the right, they both exist but not equal. So therefore, it has a jump discontinuity at that point where x equals 0. What about this last one, number 7? So we have f of x is equal to x squared minus 2x minus 3 if x is to the left of negative 1, including 1. I mean, including negative 1. It is x squared minus, plus 3x plus 2 if x is to the right of negative 1. Okay? So we have possible point of discontinuity at negative 1, although the domain of this is the set of all real numbers. So let's see if it is connected at x equals negative 1, these two graphs of f of x when x is less than negative 1 and f of x when x is greater than negative 1. Again, the domain of this is negative infinity to positive infinity. Although the domain is the set of all real numbers, possible discontinuity at what? at x equals -1. Let's check. Oh, for sure, f of -1 is defined. We use the first expression, -1 quantity squared minus 2 times -1 minus 3, 1 plus 2, 3 minus 3, that is 0. What about limit? Limit as x approaches -1 from the left. We use the first expression. So this is -1, quantity squared minus 2 times -1, minus 3, we apply direct substitution rule. So that is also 0. What about from the right? Limit, as x approaches -1 from the right, we use the second expression. So that is, again, we can apply direct substitution here because this is a polynomial. Plus 3 times -1 quantity squared plus 3 times -1 plus 2. So this is equal to 0 also. Since the limit from the left and limit from the right at x equals -1 both exist and are equal, so we say that the limit of f of x as x approaches -1 exists and it is equal to 0. Since f of -1 is equal to the limit of f of x as x approaches -1 are equal, they are both real numbers. So we conclude that f is continuous at x equals -1. So meaning it has no point of discontinuity. F is continuous at x equals what? -1. This implies that f does not have a point of discontinuity. No? F has no point of discontinuity. Okay? So this means f is continuous at every x in the interval -infinity to +infinity. Okay? Well, that's it. So that is how to determine whether a function has a discontinuity at a number, and how to determine whether it is removable, infinite, or a jump discontinuity.